Okay, so let's jump down to part D. We've got those two graphs to think about, and now we're supposed to ask ourselves what happens as n goes to infinity. So that's what this right here means. N is getting bigger and bigger and bigger without bound. That's what that tells me. And we're supposed to decide what our answer tells us about rats and what it tells us about the graph of G. So we could just refer back to the graph, but I think we should also be able to look through the formula. So I've copied it down here. And what we are saying is that n is getting really, really big. And if n gets really, really big, 12 divided by a giant number is a really, really small number. So this whole fraction is going to 0, really, really close to 0, which means as n goes to infinity, the function f goes to 3. So I'm actually going to answer these in backwards order. What does it tell us about the graph? If you're looking back up at your graph, what that is your horizontal asymptote. That's what horizontal asymptotes are. They're a global behavior. They're what happens to your function as your input gets really, really big positive or really, really big negative. In terms of rats, n is the number of trials. So as the number of trials gets infinitely large, the time, which is what our output represents, the time to complete the maze is basically leveling off at 3. So it's decreasing down to 3 minutes and leveling off there. So we do want to be realistic. This is about rats. They're not going to do an infinite number of trials, but I still think we can do a great job of expressing this horizontal asymptote meaning in terms of rats. So we could say as the rat does more and more trials, that's a really nice way to say that n is getting bigger and bigger. The time to complete the maze is decreasing to 3 minutes. Something along those lines would be great. Saying leveling off is great, anything like that. But do make sure that you say something about the number of trials getting big and the time to complete the maze getting small. Okay, last one here is average rate of change. We've done this already, but let's just do one here and do the explain your meaning. So we have our formula. Let's find f of 4. Our formula says that f of 4 will be 3 plus 12 over 4. I think I did this above, but we'll write it out here. 12 over 4 is 3, so we're getting 3 plus 3 is 6. F of 6 is 3 plus 12 over 6, which will be 5. So if I want to do average rate of change from 4 to 6, I will take the f of 6, which is 5, minus the f of 4, which is 6, and I will divide it by the change in x, which is 6 minus 4. So this is f of 6 minus f of 4 over 6 minus 4. And note that the f of 6 is above the 6, the f of 4 is above the 4. It wouldn't matter if you reversed both of those, but if you put an f of 6 above a 4 or an f of 4 above a 6, something is wrong. Okay, so doing the calculation, 5 minus 6 is -1, 6 minus 4 is 2, so we're getting an average rate of change of -1/2, excuse me. So there's more than one way to interpret that. We're thinking this is number of trials, and this is time to complete the trial, so time and number of trials. Okay, so we could say this is change in f over change in n. We could say the time to complete the maze is decreasing by 1 minute for every 2 additional runs through the maze on average. This is just an average, it's not perfect. Or we can convert that to a decimal. This would be called the unit rate because it's over 1. And sometimes that makes a little more sense in terms of averaging, because now we would say the time to complete the maze decreases by half a minute or 30 seconds for every additional trial on average. And I want to add even one more thing. I think you should be clear about the 4 to 6 trials that we looked at. So I'm going to actually write this one out. I've been lazy about it, but we'll do it here. So for trials 4 through 6, The time to complete the maze decreased by half a minute per trial on average. Your wording doesn't exactly have to mirror this, but I just wanted to write it down so I could highlight some of the really important things here. Mention the interval that you're working on. Make sure that you mention increasing or decreasing and by how much per what, and make sure you include numerical values and units. So half of a minute, numerical value in unit, and this is kind of implied, it's one trial per one trial. And then mention that it's an average. We want to be honest about what we're actually saying here. We're not saying that's exactly perfectly what happened. We're saying that's what it averages out to. Sometimes it might match up perfectly, but other times it doesn't. So let's just be careful about it. Okay, let's pause there so you can try some.